And once again, I will share this wonderful message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu. I will respond as soon as I can. Okay. Today we're going to be covering section 6.7, but first of all, we're going to answer some questions from 6.6, and I had an email request from a student for 3 particular problems, so I'm going to start with those, and then we'll get on with that to the rest of questions you have. So let's go to, can everybody see a WebAssign screen here?
Yes.
Yes, sir.
All right, we're going to take a look at problem number 19. Which says AE plus BF plus AF plus BE. It says factor the expression completely. If the expression is not factorable using integers, enter prime. Now, this is 4 terms. Typically with 4 terms, we factor by grouping in groups of 2. But first, let's look at all 4 terms. And we see that there is no greatest common factor other than a 1. So breaking it up into 2 groups of 2, we look at that and things just don't seem to work. There's really no greatest common factor of the first 2 or the second 2, but recall that addition is commutative. So what if we rearranged, let's say we move the 2 middle terms and commute them so we get that. Let's see if that'll work. So now I have an A as the greatest common factor and an E plus F left over. Let's see. E plus F and a plus B. Well, yeah, I guess I'd have to switch those 2 around, which I could do. So then I'd get E plus F times A plus B. So are you okay with what I did there? Basically rearranging the terms to make it work. So
Yes.
First I moved these 2 around, and then I switched those 2 around just so that I had E plus F as opposed to F plus E. Same thing. All right, good. We're going to go on to number 24. So let's take a look at 24, which says factor the polynomial completely. If the polynomial is not factorable, select prime. So we have 5 times x minus 3 plus 10y times x minus 3. Okay, now this one's kind of tricky because typically we'd look and go, oh, I can take out an x minus 3, but there's more than that. We can also take a 5 out. So I'm going to have a 5 times x minus 3, and then left over is going to be a 1 plus 2y. Everybody see how that worked? Because I can take out the x minus 3, but I can also take a 5 out of both of those terms, so then I need a 1 plus 2y left over. Any questions on that? All right, we'll move on. Finally, number 25, which says factor the expression completely. If it doesn't factor, then declare that it's prime. And we've got 16d squared minus 56dz plus 49z squared. Okay. Now, this is a trinomial. It's in standard form in terms of d. D squared, d, no d at all. You could rearrange it and turn it around and make it in standard form in terms of z, but if it ain't broke, don't fix it, right? There's no greatest common factor. It looks like it could be a perfect square because there's a square up front plus a square at the end. So I'm going to go with that and see what happens. 16d squared would have to be 4d and 4d. 49z squared would be 7z and 7z. But the middle term is negative 56dz, so I need to have a subtraction sign. This is going to give me negative 28dz, another negative 28dz, which will add up to negative 56dz, excuse me. So there's the answer. Or you could write it 4d minus 7z, that quantity squared. All righty. So that was the questions that came by request. Are there other questions that you have for me from 6.6 from yesterday?
No, sir.
All righty. Then we will go on to section 6.7. Okay. So 6.7, here we go. Suppose I had the following equation. A times B equals 0. What could you tell me about A or B?
One of them has to be 0.
Right. So we'd say either A or B or both A and B equals 0. This is called the zero factor property. We're going to use this property in conjunction with factoring to solve equations of second degree or larger. So we're going to be dealing with equations that have more than one solution. All right. So we're going to start off with something like this. Let's say we have x plus 3, the quantity, times x minus 2, the quantity, and we know that that is equal to 0. So what I have is a factor times a factor equals 0. So using the zero factor property, I could say that x plus 3 equals 0, or x minus 2 equals 0, or perhaps both of them equal 0. All right? So if x plus 3 equals 0, we would subtract 3 from both sides of the equation and get x equals negative 3. If x minus 2 equals 0, we would add 2 to both sides of the equation and get x equals 2. So we have, in fact, 2 solutions. Let's check our work. If x is negative 3, this factor would be negative 3 plus 3, which is 0. Well, 0 times anything is 0, so I really don't even need to put the negative 3 in the second factor. Likewise, x equals 2, if I put that in the second factor, I'll have 0, and anything times 0 equals 0. So these 2 solutions, x is negative 3 and x is 2, both work. So there's 2 solutions to that equation. Any questions? All right, let's take the following equation. X squared plus x minus 6 equals 0. Here we have an equation, and in fact it is a second degree equation. Why is it a second degree equation? Because the highest powered exponent on a variable is a 2. What we're going to do is, again, use the zero factor property. We have the equation on the left side set equal to 0 on the right side. The left side of the equation is in standard form, and so I'm going to factor it. And let's see, the x's would get split up like that. I need a product that's negative 6 and a sum that's 1. How about 3 and negative 2? So I get that. x plus 3 times x minus 2 equals 0. So then I would take each factor that contains a variable and set it equal to 0 and solve it. The first equation, I would subtract 3. The second equation, I would add 2. So I get x equals -3, x equals 2. Let's check our work. Now we could check it right here, but what if we factored it incorrectly? So it's best to go all the way back to the original problem, even though it's more work. If x is -3, we'd have -3 squared plus -3 minus 6 equals 0. -3, the quantity squared is 9. 9 plus -3 minus 6 equals 0. 0 equals 0. So x equals -3, checks. If x is 2, we have 2 squared plus 2 minus 6 equals 0. 4 plus 2 minus 6 equals 0. 0 equals 0. So again, both solutions check. Any questions about this example?
Nope, sounds good.
All right, here's another example. Let's say we've got x equals -x squared plus 6. Let's see if I did that right. Yes. Okay. What I'm going to do is I'm going to take this equation. I can see that it's a second degree equation, and I'm going to put it in standard form. Now, standard form would be like ax squared plus bx plus c equals 0. Since it's an equation, standard form is having it equal to 0. Now, recall from previous sections that we'd like to have our leading term positive. Right now, I've got a -x squared on the right. If I moved it to the left, it would be positive. So what I'm going to do is I'm going to add x squared to both sides of the equation, and I'm going to subtract 6 from both sides of the equation. So now I have a second degree equation in standard form. All right. So the next thing would be to factor the side of the equation that is not 0. And when I do that, I get x plus 3 and x minus 2. Okay. And solving it, I get x plus 3 equals 0 and x minus 2 equals 0. So then the first equation, subtracting 3 from both sides, I get x is -3. The second equation, adding 2 to both sides, I get -2. Did you notice that I did the same equation 3 different times? If you're awake this morning.
Yes.
What I did, each time I got further and further away from standard form. This first equation, the first problem I did, was already set equal to 0 and already factored, so all the hard work was done. I just took each factor that contained a variable, set it equal to 0, and solved it. The second one was already in standard form. It was set equal to 0, but I had to factor the left side first. The third one was way out. It wasn't even set equal to 0. It wasn't in standard form. So the first thing I did was get it into standard form. Then I factored it, took each factor, set it equal to 0, and solved it. So a problem in any one of those forms might come at you for you to solve. Okay, so let's take a look at some more examples. And I'm going to put on my glasses so I can see what I'm doing here. How about this one? X plus 5 times x minus 7 equals 0. So we have an equation set equal to 0. The left side of the equation is already factored. So we're going to take each factor that contains a variable and set it equal to 0. Any questions so far? All right. Then we'll take each of those first degree equations and we'll solve them. So we get x is -5, x is 7. 2 solutions. Any questions on that example? All right. Here's another example. Negative 6t times the quantity 2t minus 9 equals 0. Once again, it's set equal to 0, and the left side is already factored completely. So I'm going to take each factor that contains a variable and set it equal to 0. Then I'll go back and solve each first degree equation. So basically we're taking a second degree equation and breaking it apart into two different first degree equations. The left equation, I'll divide both sides by negative 6. 0 divided by negative 6 is 0. The right equation, I will add 9, so I get 2t equals 9, then divide by 2, t equals 9 halves. So t equals 0, t equals 9 halves. Again, any questions about that?
On the homework, would we be allowed to put it in decimal instead of 9 halves, or would you like us to keep it like that?
I don't know if they would accept it, but typically I would say, unless the problem has decimals in it, I would use fractions for the answer. Yeah, typically, like I said, it could be done, but most likely they'll want fractions. Good question, though. Clarification there. All right. Here we have, let's see, n times n plus 1 times n minus 6 equals 0. We have three what are called linear factors. They contain a variable of first degree. If we multiply this all together, it would be a third degree equation, which is why we're going to get three solutions. It's already factored, set equal to 0. So we'll take each factor that contains a variable, set it equal to 0, and solve it. If n equals 0, well then n equals 0. So that's the solution to the first equation. Subtract 1 from both sides, n equals negative 1 is the solution to the second equation. Add 6 to both sides, n equals 6 is the solution to the third equation. Now, a common mistake that students will make, they'll get a problem like this on a test. And instead of seeing it for what it is, that the hard part's already been done, it's already factored, set equal to 0, they'll multiply everything together and then pull it all apart again. And they'll waste a great deal of time for nothing. So if it's already set equal to 0, and then the other side is already factored completely, you're ready to just take this step that I did right here. Any questions about that? Okay, let's take a look at some problems that aren't already factored. A squared minus 17a plus 60 equals 0. So this is a second degree equation in standard form. One side is set equal to 0. The other side, the variable is in descending powers. All right. So now we're going to factor the side that is not 0. It's a trinomial. It doesn't have a greatest common factor. It's not a perfect square. It has a leading coefficient of a 1. So I'm going to break it apart, a and a. It has a product of 60 and a sum of negative 17. Since the product is positive, we've got to have two positive or two negative factors. Since the sum is negative, we've got to have two negative numbers. How about negative, let's see, negative 12 and negative 5? That would give us a positive 60 and a sum of negative 17. So this is going to be a minus 12, a minus 5. All right, now I'm going to take each factor that contains a variable and set it equal to 0. Can you see that we're using that factoring? In fact, we're going to be using it in the rest of the chapter and in the next chapter as well. So you really want to master factoring. Or maybe you don't want to, but you really need to. Okay, so if a minus 12 equals 0, adding 12 to both sides of the equation, we get a equals 12. If a minus 5 equals 0, adding 5 to both sides of the equation, we get a equals 5. So once again, a second degree equation has two solutions. Any questions about this example? All right, we'll continue on then. How about this one? X squared minus 36 equals 0. Well, this is a second degree equation. It's in standard form, set equal to 0. On the left side, we don't have a trinomial, but it still is a second degree polynomial. On the left side, we have the difference of two squares. So one of the factors x plus 6, the other factor x minus 6. So take each factor that contains a variable, set it equal to 0 and solve it. So x plus 6 equals 0, subtract 6 from both sides, x is negative 6. X minus 6 is 0, add 6 to both sides, x is 6. Oh, let's check our work. I've been lazy and haven't been doing that. If x is negative 6, we'd have negative 6 squared minus 36 equals 0. Negative 6, the quantity squared. Negative 6 times negative 6 is 36. 36 minus 36 is 0. 0 equals 0. Now let's say x is 6. We get 6 squared minus 36 equals 0. 36 minus 36 equals 0. 0 equals 0. And again, both solutions check. Let's see here. How about this one? 16z squared minus 25 equals 0. So again, we have a second degree equation set equal to 0, so it's in standard form. The left side, I believe, is going to be the difference of two squares. We've got a 4z and a 5, a 4z and a 5. So then we get 4z plus 5 equals 0, 4z minus 5 equals 0. Solving the first equation, subtract 5 from both sides of the equation, and then divide both sides by 4. So z equals negative 5/4. The second equation, add 5 to both sides of the equation. 4z equals 5, divide by 4, z equals positive 5/4. So again, we get two solutions to a second degree equation. Any questions about that one? Okay,
No.
Let's see here. How about this one? X squared plus 6x plus 9 equals 0. So we're back to having a trinomial set equal to 0. It's a second degree equation, so it should have two solutions. This is a perfect square. So we have two identical factors. So x plus 3 equals 0, x plus 3 equals 0. Subtract 3 from both sides. Same thing over there. So I'm going to get two solutions. They are not unique solutions. Since it's a perfect square with two identical factors, it has two identical solutions, but there still are two solutions. Okay? Any questions there? All righty. How about this one? X squared equals 5x. Well, this is a second degree equation, see the x squared, but it's not in standard form. Now, x squared is a higher powered term than 5x, so I want my x squared, that's going to be my leading term. I want it to have a positive coefficient, and it already does. So I'm going to move the 5x to the left side rather than moving the x squared to the right side, because if I move the x squared to the right side, it'll have a negative leading coefficient, and we don't want that. So I'm going to subtract 5x, oops, from both sides. Now, at this point, a common mistake that students will make is they'll look at this and they'll say, oh, it's a binomial, and there's a subtraction sign. It's x squared minus, oh, wait a minute. It's not the difference of two squares, and so then they'll either stop because they're stumped, or they'll write prime. But before you do any of that, you need to do what?
Take out the greatest common factor.
Bingo. Take out the greatest common factor. And then take each factor that contains a variable and set it equal to 0. So we get x equals 0, add 5 to both sides, x equals 5. Let's check our work. If x is 0, we'd get 0 squared equals 5 times 0. 0 equals 0, so that one checks. If x is 5, we'd get 5 squared equals 5 times 5. 25 equals 25, so that one checks as well. Okay, let's see here. How about this one? 3x squared plus 14x equals -8. So this is a second degree equation, but it's not in standard form. So I want to get a 0 on one side of the equation. I'll do that by adding 8 to both sides. But on the other side of the equation, I want my terms in standard form. So I'm going to write 3x squared plus 14x plus 8. Okay, so now I've got a second degree equation in standard form. On the left side of the equation, I have a trinomial. Well, I've already said it's in standard form. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. So I'm either going to use grouping or trial and check. I will use grouping when I'm done. If you want me to go back and do it the other way, I'm happy to do it that way at no extra fees to you or your family. All right. So A is 3, B is 14, C is 8. The product is 24. The sum is 14. The numbers are 12 and 2. 12 times 2 is 24. 12 plus 2 is 14. So now I've got 3x squared plus 12x plus 2x plus 8 equals 0. I'm taking the middle term and splitting it up into two separate terms whose coefficients are these two numbers, just like we did back in section 6.3. Now I'm going to use factoring by grouping on the left side of the equation. The greatest common factor of the first two terms is a 3x. The leftovers are x plus 4. So hopefully the leftovers on the right side of that vertical line will also be x plus 4. And if I put a plus 2 there, I see that it works. Continuing on, I'm going to get x plus 4 times 3x plus 2 equals 0. So now I have it in that factored form, okay? But it keep going. In fact, what I should have written up here, the directions would say solve, okay? So I've factored it. I've set it equal to 0 and factored it, but I haven't solved it yet. So now I'm going to take each factor that contains a variable and set it equal to 0, and then solve each first degree equation. So x plus 4 equals 0, subtract 4, x equals -4. 3x plus 2, whoops, equals 0, subtract 2 from both sides. 3x equals -2, divide by 3, x equals -2/3. Once again, second degree equation, two solutions. pretty much just about everything in this chapter is going to be either factor it, or if it's an equation, solve it. And you're going to solve it by factoring it set equal to 0. Again, any questions yet? Okay. Let's see. Let's take a look at this one. 6x squared plus 1 equals 5x. So again, I see that this is a second degree equation because of the 2 on the variable. Okay. So I want to put it in standard form, everything on one side of the equation set equal to 0 on the other side. Well, 6x squared is going to be my leading term. It's already positive, so that's good. Let's just leave it alone. So we'll subtract 5x from both sides. So I get 6x squared minus 5x plus 1 equals 0. So there we have it in standard form. On the left side of the equation, the trinomial, there's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1, so I'm going to use grouping. A is 6, B is -5, C is 1, the product is 6, and the sum is -5. How about, let's see, -6 and -1. Well, that gives me the right product, but that gives me a wrong sum. How about -3 and -2? The reason I wrote that other one is that's a typical wrong answer that I see a lot of times. So you got to be really careful that it meets the product and the sum. So -3 and -2. So now I'm going to take my equation and rewrite it. 6x squared minus 3x minus 2x plus 1 equals 0. Splitting the middle term into 2 terms whose coefficients are these 2 numbers. Factoring by grouping, the greatest common factor of the first 2 terms is a 6. Whoop, no, it's not. It's a 3x with a leftover of a 2x minus 1. Guess I better slow down there. And the greatest common factor of the second 2 terms would have to be a 2x minus 1. And let's see, if I put a minus 1 out there, I believe that gives me what I need. So now I've got 2x minus 1 times 3x minus 1 equals 0. So now it's factored, set equal to 0. I'm going to take 2x minus 1 and set that equal to 0, 3x minus 1, and set that equal to 0. Okay, so 2x minus 1 equals 0. We'll add 1 to both sides. 2x equals 1, divide by 2, and x equals 1/2. 3x minus 1 equals 0, add 1 to both sides, 3x equals 1, divide both sides by 3, and x equals 1/3. There appears to be a little sign there. Let's get rid of that. Okay. All righty. Any questions there?
No.
Okay. Let's see here. 5m times 5m plus 8 equals -16. Did any of you watch the Seahawks game on Sunday?
No.
Nobody
Sorry.
did. Okay, well, an interesting thing happened, and I won't name the player, I don't remember his name anyway, but one of the players for the Seahawks caught the ball as he was running towards the end zone. He had about 10 yards to go, but he started celebrating and taking it easy before he crossed the goal line. And he just kind of held the ball there as he trotted along the last 10 yards. But a defender came up behind him and knocked the ball out, and it ended up not being a touchdown. Extremely embarrassing for the guy. Fortunately, he made a touchdown later to win the game, so he rectified the situation. But my point of that story is don't celebrate too soon. Now, what does that have to do with this problem? When we're looking at it, the left side of the equation is factored, isn't it? Woohoo! It's all factored. We don't have to oh, but wait a minute. The right side is not equal to 0. Well, it's called the 0 factor property, not the -16 factor property. Having the left side factored equal to -16 is not factored set equal to 0. So not only is this thing not in a nice form, it's a long ways away from a nice form because we have to get the right side to be 0. So we've got to take the left side that's factored, multiply it all together, then move the -16 over, and then factor it. So don't celebrate too soon. All right. On the left side, 25m squared plus 40m equals -16. I'm going to add 16 to both sides of the equation. 25m squared plus 40m plus 16 equals 0. Now it's in standard form. So now we can go back and factor the left side, but it's got to be set equal to 0 for this to work. Let's see, it's a trinomial. There's no greatest common factor. It looks like it might be a perfect square because it starts with a square and ends with plus a square. So if that's true, it would be what? 5m and a 4, 5m and a 4, and it would have to be a plus in the middle. Let's see. If I multiply that back together, I get 25m squared up front, plus 16 at the rear, and I get what? Plus 20m, which is plus 40m. So it's a perfect square. I have two identical factors set equal to 0. So now I'm going to take each factor and set it equal to 0. And solving the first equation, I subtract 4 from both sides and then divide by 5. So m equals -4/5. And this one, I'm going to get the same thing, aren't I? Because it was the same equation. So I get two identical solutions of m equals -4/5. But again, don't celebrate too soon. All right. Let's see here. How are we doing? X cubed minus 7x squared plus 10x equals 0. So here we have a third degree equation set equal to 0. It's in standard form, but notice we have a 3 as an exponent. So this is a third degree equation which should have 3 solutions. Now, on the left side of the equation, this trinomial, oh, there's a greatest common factor of an x. So we'll take the x out. All right. Now, continuing to factor further, we have a trinomial that has a leading coefficient of a 1. So I'm going to split it up, an x and an x. The product is 10 and the sum is -7. How about -5 and -2? Okay, so I have 3 factors, each containing a variable equal to 0. So I'm going to take each factor and set it equal to 0, and then solve the equation. So if x is 0, well then x is 0. So that's one of the solutions. X minus 5 is 0. We'll add 5 to both sides. X equals 5. That's another one of the solutions. X minus 2 equals 0. We'll add 2 to both sides. X equals 2. That's the third solution. So again, third degree equation, 3 solutions. Any questions on this one? Okay, let's see here. Here's a problem where they've factored it partly, but not necessarily completely. So that x minus 1 is factored completely, but the x squared plus 5x plus 6, I think we can factor it further. So we'd have a product that's 6 and a sum that's 5. 6 and 1, nope. 3 and 2, that's going to give me a product and a sum that I need. Plus 3, plus 2. Take each factor that contains a variable and set it equal to 0. And then solve it. X minus 1 equals 0. Add 1 to both sides. X equals 1. X plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. X plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. And there you have that. Okay, let's see here. Let's take a look at this one. 6n cubed minus 6n equals 0. This is already in standard form, descending powers of the variable set equal to 0. Okay. There's a greatest common factor, 6n. So I've got n squared minus 1. So then this becomes what? N plus 1, n minus 1 equals 0. So 6n equals 0, n plus 1 equals 0, n minus 1 equals 0. 6n equals 0, divide both sides by 6, n equals 0. N plus 1 equals 0, subtract 1 from both sides, n equals negative 1. N minus 1 equals 0, add 1 to both sides, n equals positive 1. Okay. Questions there? All right. Let's see. X squared plus 4x minus 21. X squared plus 4x minus 21 equals 0. We have two different situations. We have the same trinomial, but in the first case, it's just an expression. It's not an equation. We can factor it, but we cannot solve it because it's not an equation. Let's see, product of negative 21, sum of 4, negative 7, and 3. Oh, no, plus 7 and minus 3. Is that right? Yeah, we'd have to have a plus 7 and a minus 3. That's as far as I can go. It's not an equation. I can only factor it. Now, the second one is an equation. It's going to have the same factors, but now I need to go on and solve it. So the directions for this first one would be factor, and for the second one would be solve. So here I get x plus 7 equals 0, x minus 3 equals 0. So x is negative 7, x is 3. So if it's an equation, be sure to solve it. If it's not an equation, don't just take this and magically set it equal to 0 and solve it. I have students doing that. Don't be one of them. All right. Let's see here. How about this one? Q squared minus 1/4 equals 0. Well, this is a second degree equation in standard form. Is that the difference of two squares? Q squared is a square. Is 1/4 a square? What's 1/2 times 1/2? That's 1/4, right? So yeah, so we've got Q plus 1/2, Q minus 1/2, because 1/2 squared equals 1/4. So this is the difference of two squares. So Q plus 1/2 equals 0. Q minus 1/2 equals 0. I'm going to subtract a half from both sides. Q equals negative a half. I'm going to add a half to both sides. Q equals positive 1/2. So 2 fraction solutions to that equation. Let's see here. One more. X cubed plus 7x squared equals x squared minus 9x. Well, I can see that this is a 3rd degree equation. If it's anything larger than a 1st degree, so a 2nd degree or larger, I want to put everything on one side, set equal to 0. My leading term is going to be that x cubed. It's already got a positive coefficient, so let's leave it there. Let's move everything from the right side over to the left side. So I'm going to subtract x squared, and I'm going to add 9x. So on the left side, I get x cubed plus 6x squared, because combining those like terms, plus 9x equals 0. Okay, so now it's set equal to 0. It's in standard form. There's a greatest common factor of an x, so I'll take that out. And then the trinomial, it looks to me like it's a perfect square. And I think it is. Yes, it is. So I've got 3 factors. So x equals 0. X plus 3 equals 0. So x is negative 3. X plus 3 equals 0. So x equals negative 3 again. So there's 3 solutions. One of them is unique and the other one is repeated. So negative 3 appears twice, but there still are 3 solutions. All righty. Well, that's it for today. So for tonight, 6.7. And I'm going to stop the recording.